honor for me to be a part of this lovely program. So am I audible properly?
You are.
Okay, so I am sharing my screen. Okay, is my screen visible? Okay, so this is one folder which I have shared. This is the shared drive. So is this folder is shared with everyone? Okay, so in this folder, course content, there is one another folder which is day 3, and inside day 3 there is a folder lab. So is this lab folder of the day 3 folder is visible to all of you? Once check it. Is it visible? Okay, okay, it is visible. So first download this lab folder. So right click on it and download it. So it is downloading. Okay, after downloading it, go to your folder in which this file get downloaded. Just let me delete another. Okay, so this is the compressed file which is downloaded. So first uncompressed it. So extract all the contents of this folder. So this is the content. So first you have to upload this folder lab to your Google Drive. So suppose uh, this is my Google Drive. So inside this Google Drive, I am uploading this folder. So to upload it, right click on this new icon, then click on folder upload, and after it select the path of the folder which you want to upload. So we want to upload this lab folder. So click on it and upload it. It is uploading. Okay, so this is the folder which got uploaded. So here in this there are two more folders, in which one folder is of the contains all the real data sets. Another folder contains two-dimensional synthetic data sets. Okay, someone is facing problem in accessing the folder. So okay, we will later give you more details about if someone is still still facing difficulty in accessing the shared folder. So no worries about it. Uh, so here in this folder there are two more folders, which first folder real contains all the list of few real data sets, and the synthetic folder contains few two-dimensional synthetic data sets, and there is one Python notebook file, so which contains the code. So in this lab session, we will discuss the demonstration of the most basic clustering algorithm and the most well-known clustering algorithm, which is known as k-means. So inside this notebook, there are codes divided by cells. So you have to just run these cells and to run this code. I have another notebook here in which I will do this few parts of the code from scratch for the better understanding. So first you have to connect it. So to connect it, click on this. Okay, 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 sure. I will pace down. I will slow down my pace. No worry in it. So to run this code, first you have to connect this. So to connect it, click on this connect button. Okay, after connecting to the Google server, you can run it. Suppose we want to run this cell, so just click on it to run this cell. Okay, okay, I am sharing it. Yes, yes, you have to open the IPyNB file, which is uploaded to the drive, which is this file. I don't know, maybe this link will work if it is shared to you. Someone is still facing problem. So if it works, I don't know. Okay. So okay, I'm repeating it once again. First, go to this shared folder, which is this which is this shared folder. Inside it, go to the course content and go to the day 3 folder. Inside it, there is one directory named as lab. So first download this directory. After downloading it, you will get mm, this compressed file. So first uncompressed it. So you will get this folder. So you have to upload this folder on your Google Drive. So first go to your Google Drive. So this is my Google Drive. Then you have to upload the folder which you have downloaded. So click on this new button, then click on this folder upload, then inside it select this folder lab and upload it. So after uploading it, you will get this folder lab. Inside this lab folder, you will get this k-means Python. You will get this Python notebook file which named as k underscore means. So open it. Then you have to then to run this code, I will explain it in this Colab notebook by scratch, and in parallel you have to run this code by clicking on this cell. So you have to just do this, and if you are guys facing some problem, I will handle it. So how many of you have uploaded this lab folder successfully and able to open this k underscore means Python notebook file? Okay, okay, thank you for the response. Okay, thank you for the response. So here I am working on this notebook file. So first we have to load the required packages and libraries. So to load it, first we are using numpy package. The numpy package means numerical Python, in which we perform many operations related to mathematics and represent the data. Okay, someone wants some more time. Okay. Okay, upload it, there is no issue, and then start running these cells. Okay, I will ask once again later about the status. So here first you need to import the required packages and libraries. So first package which we will use is numpy. So import numpy, use import numpy, and I'm giving it an alias name which is np. So this numpy package contains, we can perform many operations using this numpy package, which are related to the mathematical operations, and we can store data in the form of arrays. Then another package, since we are working on the CSV files, and we wanted to perform some read and write operations on those CSV files. So we are using pandas library. So to import pandas library, use import pandas, and I'm giving it an alias name which is PD. Then again, to visualizing the data, since we will also see how to see the um, and how to see the effectiveness of any of a clustering algorithm on the two-dimensional synthetic data sets. So we will visualize some data. So for it, we are using matplotlib library. So from matplotlib package, there is one another sub package which is pyplot. So I am importing pyplot and aliasing at it as PLT. Now, after importing the required packages, next we will perform the read operation on the CSV files. So here, so first to perform any read operation, we have to perform, um, we have to mount the drive because our data set files will be on the Google Drive. So first we have to mount our Google Drive. To mount the Google Drive, first click on this files icon, which is the fourth icon in the leftmost panel. Then click on this third icon, which is mount drive. So mount it. By it, you will get some required, it is required to do some accessing some permissions, or if you got this snippet of code, so just run it. Click on connect to Google Drive and give the access through your valid Google account. Okay, so our drive got mounted. So after mounting the drive, on this left panel, we can navigate through the directories of our drive. So inside drive folder, since there is my drive folder, and inside my drive, I have already uploaded this lab folder in which there are required data sets. First, we will work on the synthetic data sets. So through where you have uploaded your code to the drive, navigate till this synthetic folder, and inside all these data sets are in the form of CSV files. All these data sets are in the form of CSV files. So to okay, I am clearing your doubt just after 5 minutes. So after, suppose there is one aggregation underscore k equal to 7 named file. So click on it. So after clicking on it, you can see its content. So here, this in this data sets, each row represents one data point. So this is one data point, this is second data point, this is third data point. Starting two columns are representing the value of the data points along the first and second feature. So this first column represents the value of the data along first feature. The second column represents the value of the data along second feature, and the last column represents the cluster labels, which is the ground truth cluster labels, which means that this first data points having the value of along first dimension is 15.55. The value of second dimension along first data point is 28.65, and this is the cluster label, means first data points, the first data point belongs to cluster 2. So first, to read this the file, we will use pd.read csv. So type pd dot read inside pd there is one function pd read underscore csv. So we are calling read underscore csv function. The first parameter of this function is the path of the file. To get the path of the file, click, suppose we want to open this aggregation file. So click on this three dot and click copy the path by clicking this second last option. So by this, the path got copied between the inverted commas, paste it. So this is the first parameter. The second parameter is the separator in among separator by which the values are divided. So here we can see that in this aggregation data set, each the values of each row is separated by a slash t symbol. So the second parameter is the separator. So in this case, to open it, we are passing its separator as slash t, and just run it. Okay, so we got this. So since we can see its output, so this we read this CSV file successfully, and using pd.read CSV, and you can see its data. I am so this is returning a data in the form of data frame data structure, and so I am storing this data frame into the reference variable df. So just to print the just top rows of this data frame, just use df.head. Okay, so by this you can read the data set. So let's see now doubts. Okay, so the first doubt is difference between working with Google Colab and Anaconda. So the first thing is that this Google Colab is the on a online platform through which you can code in the form of notebook through Python, and it provides online server, so you can so the environment of all the Pythons and the required packages libraries is online. If you wanted to run the Python codes offline in your system, then you can use Anaconda environment, which provide the complete packages and libraries of the Python. Yes. So if in Anaconda, since you already installed Anaconda if in your system, and so these three packages will come by default after installing it. So you can use pd.read CSV. Okay, cannot find synthetic folder on RHS after mounting. So click on this fourth icon. Okay, after clicking it, you will get these two directed structures. If you have mounted successfully, then these two things will be visible to you. Then click on this drive, then click on this my drive, and then you will get your directory structure, and here you will see this lab folder. Then whatever file you wanted to read, suppose I am reading this aggregation file, then click on this three dot and copy the path. Okay, should we delete the previously written part in knob notebook? Okay, it is up to you. If you are comfortable in doing code parallelly, then you can do it, or otherwise it is this space is little, there is more space for you, then you can run these codes directly. There is no problem. It first you have to just change this path, which will be according to your the path in which you have uploaded the folder in your Google Drive. Okay, I explained it. Once again, repeat, sir. Okay, so you wanted to repeat it once. I think I already just recently repeated it. How to mount the drive by first run this code to mount the drive, and then after mounting it, you have to give this path name. So by giving the path name after mounting it, just navigate. So suppose I have mounted this thing, so just navigate on this folder and go till the go till the path where your file is located. So just then after that you can read this CSV file. So how many of you completed this till here? Okay, so many of you have done. Thank you for the response. And some of them are facing problem. So again, try to mounting it. Again, I am repeating it by running this code. Give some access. After running it, on the left, you will get the file structure here, which you can see. Go to the file according to your path and copy it and then paste it. And thank you for your responses. Okay, so here you can see that the pandas library. So the pandas pack library is worked on a special data structure which is called as data frame. Data frame stores the data in the form of two dimension, in the form of rows and columns. So this is the content of a data frame which shows the starting 5 rows using df.head. If you wanted to print starting 10 rows, just call it as df.head and then pass 10. So it will print the starting 10 rows. So first let me open another example, another file. So let's say this G12 data set. By double clicking it, you can see its content on the right. So here you can see that this G12 data set also have the separator /t, which is tab, and but there is no header here. In the aggregation data set, you can see there is header which is telling some title information of each column. So here, since there is no header, so in this case, to load this G12 data set, pass it as comma header equals to none and run it. Okay, so here since I am loading this G12 data set, so I have to pass the path of G12. So all these are the synthetic data sets which are having two dimensions. And we have loaded this data set in the form of data frame using pandas package. So on this data frame, which is df, we can perform many operations like dropping some columns, retrieving some data, getting some statistical information. So one operation which we'll see is accessing some data points or retrieving some data from this data frame, which is performing indexing. So by default in pandas, we performs retrieving the data by columns. If I use df of 0, then it will return the value of the data of along the 0th column, which is this. If we have to perform indexing in the form of rows and columns, then we can use df.ilog. We can use df.ilog. So suppose we wanted to see the first row and access first row and first value first column. So we can use it as df of 1 comma 1. We can also perform slicing. Suppose we wanted the starting 5 rows of column 0. So we can type it as starting 5 columns, which is colon 5, and suppose 0th column along 0th column. So it will return these values 0.72496, this one, this one, this one, and this one. If we wanted all the value of all the data points along the last column, which is this cluster label, so we can type it as all the data points along last column. So we can type it as 2. We can also perform negative indexing. So -1 means the last column. So we can type it as -1. Okay. So here the first thing which we'll do is that separating this data frame into the data part and the cluster labels. So here we can see that the starting 2 columns are the data part. Last column is the cluster labels, which are the ground truth cluster labels. So to get the starting columns, again we want all the data points, so colon, then till the last column. So it will return the first 2 columns, which is the data part. To get the last column, type it as df.ilog, then column, then comma, then -1. So it will return the last column. In the upcoming code part, we will deal the data and represent the data into the numpy arrays, because I am more comfortable with by representing the data into the numpy arrays and performing operations in the form of numpy arrays. So to convert this data frame into the numpy array, so you can use np.array method and just pass this data frame. So this data frame is converted into the numpy array. So to convert this ground truth cluster labels, also pass it into the np.array method. Also pass the second parameter. So as we can see, there's this last column is in the data type is integer, so we are passing it as d type equals to int, and I am storing the data part into the x variable and the cluster labels part into the actual labels reference variable. Okay. Now, since by using x dot shape, it will return the dimensions of this data. So our data contains 300 number of data points and 2 number of features. So I'm storing it into some variables, which is n comma f. So n contains the number of data points, f contains the number of features. Since this is two-dimensional data set, so number of features will be 2. To get, since we are going to perform the k-means algorithm, so for k-means we also require the number of clusters. To get the number of clusters, we can use so since this actual labels contains the cluster labels of each data point. So I am converting it into the set data structure. So it will give the all unique elements. So you can see that in our data, in this data set, G12 data set, there are 3 number of clusters of cluster labels 1, 2 and 5 respectively. To get the number of clusters, just pass it into the len. We get the number of clusters. So n contains the number of data points, f contains the number of features, and k contains number of clusters. Okay, great. So let's see some doubts. There is some issues related to attendance. You can ask this in later with the would you please repeat the last sentence? Okay, so which sentence? Let's see. Oh, it's got this. So you can ask your doubt once again. So how many of you have done this till this part? Okay, df.ilog. So to perform indexing on the data frame, we use df.ilog. So if we wanted in this data set, we wanted to access the second row and zeroth column. So just you use df.ilog 2 comma 0. So it will return the element which is present at the second row and zeroth column. So since by this we can also perform slicing. So by this we are accessing all the data points because it is nothing, it is we are performing slicing here and there is no starting and ending parameter. So it will return all the data points and we want starting two columns. So that's why we are, since starting is, there is nothing starting value is here. So it will access start from 0 till last column, and last column is not included. So by this it will return the data of this data frame df along zeroth column and first column and skip the last column. By this we got the data part which is in the x, and here by this we are getting the last column which is the ground truth labels and storing it into the actual labels. Okay, so one student completed till here. Any other students? What about the remaining students? Are you completed? Okay, okay, great. Thank you for the response. Okay, so in the next part, since we are using the since here in this example we are doing clustering on the two-dimensional data set, so we can visualize those data sets into the two-dimensional space. To visualizing it, we will see the example of scatter plot on this G12 data set. So um, to do scatter plot from the PLT, call the function scatter. In this scatter function, the first parameter will be the value of the data along first dimension, which is the zeroth column, and the second parameter is the value of the data along first dimension, along the second dimension, which is this first column. So to get the all value of the data points along first dimension, which is the zeroth column, so I am accessing all the data points and getting the data along zeroth column. Similarly, pass the value of the data along the second dimension and just run this code. Okay, so here you can see the scatter plot of the G12 data set, and after visualizing it, we can see that this is in this two-dimensional data set. We can see clearly by eyes that there are three number of clusters inside these data sets. So this is cluster 1, this is cluster 2, and this is cluster 3. And our aim is to detect this cluster using a k-means clustering algorithm. So we can also perform many operations, or we can many operations on this plot. So suppose we wanted to change the size of the marker, we can pass it as s equals to 20. It will give the marker size. So here you can see that marker size got reduced. Then just call plt.show method to to show this scatter plot, and we can also give some titles to this plot also. So suppose plt.title, uh, suppose it is title, name of this title is input data set. This is the input data set. Okay, great. Now after visualizing it, we will also see the example of the visualization by assigning some colors to these three different clusters, data points of the clusters. So to visualize the ground truth labels, input data set with ground truth. First, let me comment it. So to give, suppose we wanted to change the color, suppose we are want to assign the color of each data point as red. So pass C equals to red. So here you can see that the color of each data point is red. Our task is to assign the color, to visualize the colors of each data points on the basis of ground truth cluster labels. Since we know that our ground truth cluster label is assigned in this actual underscore labels reference variable, so pass this as a parameter. Okay, let me increase some size. Let's say 40. Okay, so here you can see the visualization of this G12 dataset, which contains three clusters, and you can see that all the data points of color yellow belongs to one cluster, all the data points of color purple belongs to another cluster, and all of the data points of this blue color, shade color, belongs to another cluster, second cluster. Okay, now let me see some doubts. Oh, it is hash means just number. I am just printing it. You can use anything. We are using aggregation in this example. First, we will see this G12 data set. You can use aggregation data set also, but first see the demonstration of k-means on G12 data set. Check whether on G12 data set it will work or not. After that, perform it on aggregation data set and check uh, if is this k-means will work on the aggregation or not. So you can use any data set. Initially, I am suggesting to use G12 data set because it is the perfect example of for k-means. Okay, yeah, it is getting displayed since we are working on the uh, since we are working uh, on the notebook file. So if we haven't mentioned plt.show, then it is fine. But if we wanted to show the multiple plots in the single cell, then you have to use plt.show. That's why I'm using it. And if you will code in the Python script, then you have to use this plt show. Currently here plt.show is not mandatory. Okay, so our next task is to detect these clusters. So to detect these clusters, if you are facing some problem or some code is skipped, you can use this which I have shared. So you can use this is the same code, so you can access this. There is no issue in that. So our next is to apply k-means on this G12 dataset to detect these three clusters. So first we will see how to perform k-means using a built-in function. So there is one popular Python library which is known as sklearn. So inside this sklearn library, so since this library is stored in the form of package, so inside from sklearn package, I am importing another sub package which named as cluster. This cluster sub package contains all the list of popular clustering algorithms. So which you can directly call these all those popular functions of those popular clustering algorithms using from this cluster sub package. So inside this cluster sub package, there is one class which named as k-means. So in this lab session, we will see this class k-means because we wanted to perform k-means. So when we see the documentation of this k-means class, so you can see that this is k-means is a class inside which you have to first to create the object of this k-means class. So through its constructor, first you have to pass this number of clusters. So I am passing. So to create the object of this class, so call its constructor k-means, then pass number of clusters. So the k variable also contains already contains number of clusters. So I am passing k. You can also set the type of initial method. Currently we will see most common method which is random initialization. Then how many times you wanted to perform the key means? Suppose we wanted to perform key means 3 times. So we are passing it 3, and among all 3 the result which best results will return the result. So since so cluster dot key means, by this we an object is created. I am storing the reference of this object to this km variable. Now our task is to perform, okay, let me delete this. So our task is to perform k-means on this data set X. So from km, call a function fit and pass X. So k-means will be performed on this date on the data X, and we got the clusters. Run it. Okay, so how to get the clusters predicted by this built-in function k-means? So from km, there is one attribute which known as labels underscore. So this km underscore labels will return the cluster labels predicted by this sklearn's k-means function, and here you can see that cluster labels predicted by it. It means that the cluster label of first data point is 1, cluster label of second data point is also 1, cluster label of last data point is 2. So I am storing it into the variable predicted labels. Okay. Now let's visualize this visualize the results which are results or clustering results predicted by this sklearn's k-means function. To visualize it again, I am just we can use this scatter plot, and here we will pass prid labels. So it will show the colors of the clusters or clusters assigned to the data points, cluster labels assigned to the data points according to this k-means clustering algorithm. So input, so let's say clustering results. Let's give its title as clustering results. So here you can see that the clusters formed by this sklearn's k-means function, and you can see that it performs pretty well. So you can see that all these data points belongs to the single cluster have of color green. All these data points belongs to single cluster, and all these data points will belong to the single cluster. And by k-means, the k-means successfully detect these clusters. Okay, let's see some doubts. Okay, under scatter plot with ground truth c equals to left does not understand while using other colors does not work. I think I already explained this part, so I think there should not be further doubt here. If it is, ask once again. What does number of init stands for? So number of init, I already explained that how many times you wanted to apply k-means for the particular data set. So when km.fit is called for data set x, so k-means will run 3 times, and among all these, in this case 3 times because number of init is 3, and among all those 3 runs, the result cluster results with the best clustering results will return. Okay, just okay. So what other part? You can access this part of code if you wanted to if some part is skipped, you can access this code which is already shared with you. Okay, so okay, so let's see the next part. So in the next part, since we got these clusters, but in the next part we made a user defined functions couple of, and this is the user defined function of k-means. So in the, so here we will see this example, and also in the example, and also this user defined function which we made will give the step by step analysis or visual of the k-means clustering algorithm. So by this we will see how k-means clustering will work, how we got this final clusters. So initially, so the k-means is mainly work in, so the first step of the k-means is that first to initialize the k centroids. Then after initializing the k centroids, run the k-means algorithm for some number of iterations. For each iteration, there are two parts. The first part is that finding the clusters of, the first part is that detect the clusters by finding the closest centroid of each data point, and the second step of each iteration is that again find the new centroids of the clusters which is formed in the previous step. So how this will work, we will see by running this code. There is no issue in that. So to run this user defined function, so call this my k-means function, which contains first input parameter is x, second is k, and also some other parameters. Okay, my k-means. So from this my k-means, since we wanted to perform k-means on data set x, and a second parameter is the number of clusters which is k, and the third parameter we will passing is the maximum iteration, for how many maximum number of iterations the k-mean will run. The maximum iterations, we suppose say 20 is enough, and pass is plot as true, means that it will give the visualization step by step. This will return these three parameters, which is the cluster, run it. Okay, great. So here there is an example. The first step, as it is mentioned in this step, is to initialize the centroids. So in the first step, these three, since we wanted to find three number of clusters, so these are the three initial centroids which selected randomly by selecting three data points randomly. So these three data points selected randomly and treated as the initial centroids. After it, there are two steps of each iteration. So for the iteration 0, the first step is to assign the closest centroid to each data point. So this is the initial centroids. So all these data points of green in color are closest to this centroid, which is in the star marker, red marker this. All the data points which are closest to, all these data points which are of color purple are closest to this centroid, and all data points of that are in color yellow are closest to this centroid, which is in the red marker. So here by this we formed three clusters in the iteration 0. At the end of iteration 0, the second step is to recalculate the centroids of these formed clusters. So for this green colored cluster, the centroid is this blue marker. For this yellow colored clusters, the centroid is this, and for this for this purple colored cluster, centroid is this blue marker, and for this yellow colored cluster, the centroid or center is this blue marker. So at the beginning of iteration 0, these are the centroids on the basis of which we got these three clusters by assigning each data point to its closest centroid, and at the end of iteration 0, we got these three new centroids by recalculating the centroids of the new clusters. So for iteration 1, these blue colors will act as the centroids at the beginning, which we can see in this red colored marker. So again, the steps are same for iteration 1 also. Again, assign closest centroid to each data point. So all these green colored data points having the closest centroid this marker, all these purple colored data points have the closest centroid this red marker, and all these blue colored data points, sorry, yellow colored data points have the closest centroid this red marker. Then second step is again find the centroid of these new clusters. So these blue colored markers are the centroids of these new clusters, and again repeat these steps again and again in each iteration. So by this we can see that after increasing the iteration, we will get the better and better clusters. So for example, iteration 2 contains better clusters as compared to iteration 1. Iteration 3 contains better clusters as compared to iteration 2. So in each iteration we got better and better clusters, and these centroids converges slowly to the local or optimal solution, or to get the desired clusters. So here you can see that in each iteration we got better clusters, and at the end perform this iteration until the maximum number of iterations, or until we got same consecutive centroids in each iteration. So at iteration 4 we can see that now the centroid is not shifting, it got same, so it got terminated, and at iteration 4 we got the final clusters. Also another thing is that k-means works on the aim of the k-means is to minimize the sum of squared error. What is sum of squared error? Sum of squared error means find sum of distance between the data points to its centroid. If you wanted to find the what is the SSC value of the clusters performed after iteration 0, so find the distance between each data point to its centroid. For example, find distance between this point and its centroid, this point and its centroid, this point and its centroid. Uh, find this distance for each the data points, perform the sum, and you will get the SSC. So it is actually sum of squared of distance between each data points to its centroid. By this we got the SSC. So minimum the SSC means better the clusters are. So in iteration 0, for this case SSC is something 19.1836. At iteration 1 SSC got reduced, it means that we got better clusters. At iteration 2 SSC further got reduced, it means we got better clusters, and we can see that in each iteration SSC got reduced and reduced, means we got better and better clusters, and at the end we got the desired clusters. So these are the two inbuilt functions, which this first function calculates the SSC, the second function finds the k-means. I think there is some issue, I mean not much time is left, so I'm skipping the explanation of this part, but if anyone is facing any issue at the end we will see it. If someone is facing some part of the code, we will see it. Okay, because we have to see the another important part, how to perform clustering on real data sets. Okay, there is one doubt. Show the k-means that you had written. Okay. So this is the code of the k-means which is done from the scratch, and I think this folder is already shared with you. So you can see it here. If it is skipped by somehow, you can access it here. There is no problem in that. And if you are facing some issue in some part in which you didn't get it, how it performed or how the code is done, you can ask that part. And if we got time at the end, we will discuss how this is implemented. Actually, currently we only have 30 minutes left, so that's why. So how many of you done this till now? Run this part of the code till here? Okay, thank you for the response. Okay, okay. So many of you have done this part. Great. So here in the previous the distance is Euclidean distance by default. Okay. So here in this part, we are running the k-means to see the plots or to see the visualization of each step. If we wanted to just perform k-means on a data set, just call this function my underscore k-means and pass its plot as false. So in it returns three parameters. The first parameter is the clusters, which contains the cluster labels predicted by this my underscore k-means function. Second parameter is init underscore centroid, means the centroids which is selected initially at the beginning of the k-means. In this case, the centroids are selected by selecting k random data points. And this is the final centroids which we got after running the k-means. So just print the clusters. Okay, so these are the cluster labels predicted by this my underscore k-means function. To plot it, you have to just perform again this thing. You have to just use call this scatter plot. So I am plotting it. Since this now this clusters variable contains the cluster labels predicted by this my underscore k-means function. So in this case, we are passing this clusters variable. Okay, great. So these are the clusters predicted by the my underscore k-means function. Suppose we wanted to print this initial centroids or final centroids also, so we can print it. So we have to just, since we wanted to again perform scatter plot, so plt dot scatter, first parameter will be init underscore centroids along first dimension. Second parameter will be its value along second dimension. Let's say marker will be star, and let's see, give size as 100. So these, let's also give some color, which is red. So okay, it is running. Okay, so these are the centroids which is selected initially, selected initially. Let's also give the plot of the final centroids. Okay, so these are the initial centers which are in this red star markers, and these blue star markers are the final centroids which is learned after running the k-means. So here we can see that for each run of k-means we got different results. So the reason is that the k-means is a non-deterministic clustering algorithm, means its result varies in each run for the given data set and k, and the results is depending upon the selected initial centroids. So here let's see two examples. In the first example, in which these are the three centroids which is selected, initial centroids. Here in this case, we are passing the initial centroids manually to check that how k-means work and how this centroid initialization step is important in k-means. So here in this case, you can see this is the good example of centroids initialization in which all these three centroids are well scattered. It means this initial centroid is represented in blue color in this case. So all these are the initial centroids, and here you can see that these initial centroids are well scattered. So because of this, we got this perfect clustering or desired clustering, and the k-means got the final centroids got converged to the local minima or global minima in very few number of iterations. Here, this is an example of bad centroids initialization. Here, in this case, you can see these blue colored markers, which are the initial centroids. So here you can see that in this case, for this case of centroid initialization, we didn't get the desired clusters. So here you can see that for this, on the basis of this initial centroid, we got this first cluster, we got this second cluster on the basis of this initial centered, and on the basis of this initial centered we got these three clusters. So we didn't get the desired clusters. So, and also you can see that SSE also varies hugely. In case in the first case SSE is very less, in the second case SSE is very high. So here we can clearly see that the results of k-means varies, and it results is depending upon the centered initialization technique. So to get the in general practice, to get the desired clusters when using k-means, we perform k-means multiple times and select some average result or best result. So here in this snippet of code, we can see that in this case we are running k-means 10 times and select the cluster labels or finalize the cluster labels for that run, which gives the least SSE. Least SSE means we got the best clusters. So it is the good habit or practice to run the k-means algorithm for the given data set multiple times and get the best results. Okay, let's see some doubt. Okay, there is one doubt that I want to make a change. Where to change, sir? Manhattan distance, Minkowski distance, and Hamming distance. Okay, so by default, k-means uses the Euclidean distance, but yes, you can apply another distance measures on the k-means. So for that, you have to, let's see here in this distance dot c dist, you have to, by default the distance will be the Euclidean distance. You have to just pass it as Manhattan. Let's see it's okay. Let's see uh, its definition. So in this cdist function, yes, pass this third parameter metric. You can set your desired uh, use your desired distance measure. So here in this where it is, yes, in this passed as metric equals to, suppose you wanted Manhattan, so just passed it as Manhattan. You can also see that whether what is the terminology for the list of functions. So help distance dot cdist, you see the third parameter. So you can use all these data sets. So I think for Manhattan, this is the city block data set. For Hamming distance, you can use Hamming. For Minkowski distance, you can pass Minkowski, then you can, for that you have to also pass the value of P. Okay, great. Now, okay, there is some doubt related to certification. You can ask this later. Okay, so there is no doubt here. Okay, so in the previous part, we performed the k-means clustering on the synthetic data sets, and so generally synthetic data sets are used in the clustering is to test the advantage or disadvantage of any clustering method, on what kind of data sets we can perform k-means, on what kind of clusters k-means will not detect the clusters, and also if you wanted to design a new clustering algorithm, then synthetic data sets are good to work on it initially. So here there are very we I have shared pretty some synthetic data sets. So select one by one synthetic data set, apply k-means on these data sets, and check that on what kind of data sets k-means can detect clusters, and on what kind of data sets k-means is unable to detect the clusters. So just you do this exercise from yourself. In the next part, so when it comes about the cluster performing a clustering task, we will perform it on the real world scenario. For example, clustering some custom perform clustering on for the customer segmentation, for the for movie recommendation, or any other, when there are many various of real world applications. So in the next phase we will see the example of performing k-means clustering on some real data sets. So, so here you can see that in this real folder, I have already shared you some data set. So let's see, we wanted to perform k-means on iris data set. So first we have to read this iris file. So to read this, again copy its path. Again copy its path. Then from PD call read CSV function, then pass the first parameter, which is the path of the file. The second parameter is the separator. So in this case, the separator is comma. So pass separator as comma, and also we can see that there is no header in it. So passed header as none. So I am assigning it into a df variable. Okay, so we got the data of the iris in the form of data frame. Again, in the next step, we wanted to separate the data part and the cluster labels part. So the first four columns of this iris dataset contains the data part, means the features, feature value, and the last parameter contains the cluster labels. So I'm separating it again using df.iloc, accessing all the data points, value of the data points along all the features. So I'm skipping the last column, then get the last column. It should be df.iloc. We have already seen this part, so I think there should not be any confusion in this. X comma actual labels. End. So okay, so x dot shape will return the number of data points and number of features. So we can see that in this iris dataset there are total 150 number of data points in which we have to find the clusters, and it having the total number of features as 4. So n comma f, so n contains number of data points, f contains number of features. Again, to get the number of clusters, we can convert this actual labels into set, and find its length. So n contains number of data points, f contains number of features, and k contains number of clusters. Okay, so in this case the number of clusters are 3. So we wanted to find three number of clusters in the iris dataset. Here again, to perform the clustering, since we can use this user defined function, which we can use either of the functions, either you can use user defined function, either you can use sklearns inbuilt function. So to, if you wanted to use sklearns inbuilt function, again I am explaining once again. So from this cluster, we have to create the object of this k-means class. To create the object of this k-means class, we have to call its constructor, in which the first parameter will be the number of clusters, which is k in this case. The second parameter will be the init type. In this lab session, we will see the random initialization of centroids and how many times you wanted to perform clustering. Let's say 10 times. Let's store it into the k. Okay. Now to apply k-means on the this given dataset X, call from km reference variable, call the function fit. We wanted to apply k-means on X, so pass X here. In km's in the k-means class, there is one attribute which is known as labels, which will returns the labels predicted by the k-means, cluster labels predicted by the k-means. There is no attribute. Okay, it should be labels. Okay, so here for first data point, the labels predicted by the k-mean is 0. For second data point, cluster label is 0. For last data point, cluster label is 2. And you can see that cluster label of each data point predicted by this k-means algorithm. So I am storing it into the pred labels. Okay. Okay, so the next part is very interesting. Since we are performing we are doing cluster analysis on the, we are doing clustering on the real world data set. So generally the real world data sets contains more than 2 or more than 3 dimensions. Here you can see that this iris dataset contains total 4 number of dimensions or features. So we can't directly visualize the data points or the data set if it is more than 3 dimensions. So since we can't visualize it, so in the previous case by ice we can see that, okay, whether we get the good clusters or not. But in the real data set, we can't do the perform cluster analysis or check that we got quality of clusters or not just visually. So to check that whether any clustering algorithm predicted good clusters or not, or good quality of clusters or poor quality of clusters, we can check it by some performance measures or validity indices. In k-mean, in clustering, there are generally two types of measures to check whether the given predicted clusters are of good quality or not. The first category is the internal quality measure. The second type is the external quality measures. So we have already seen a famous internal measure which is SSE. And in k-means, with the help of SSE, we can easily check that whether the clusters predicted by any clustering algorithm or the k-means clustering algorithm is good or not. Lesser the SSE means we got the better clusters, higher the SSE means we got the poor clusters. So with the help of SSE, we can check that whether we got the desired clusters or not. So to check it, we have already made this function cal_SSE, and it requires 3 parameters to call it. So I am just using this cal_SSE function. So its first parameter is a data which is already X. The second parameter cluster_data requires nothing but the cluster labels predicted by the k-means algorithm, which is already inside this pred_labels variable. The third parameter is the centroids, final centroids, which is learned by the k-means. So to get this using the sklearn, So using KM, there is one attribute which is known as cluster underscore centers. So this this KM dot cluster underscore centers underscore will give the final centroids which is learned by the k-means algorithm. So this is the first centroid learned by the k-means sklearn's k-means algorithm. This is the coordinates of the second centroid. This is the coordinate of the third centroid or the third cluster center. So I'm just passing it. So by this we got the SSE value. So we got some SSE value. So I'm storing it into a variable SSE and just printing it. So there is no limit of SSE because it works on the distance measure. In this case, Euclidean distance. So there is no limit in that. So we have to just check the value. Less SSE means the good clusters. High SSE means bad clusters. Another category will be the external measures. External measures. So here in this lab session, we will see two popular external measures. External measures means finding the quality of the clusters on the basis of some indices which uses the cluster labels, predicted cluster labels as well as actual cluster labels. So in internal measures means that we are finding the quality of the clusters without using the actual clusters. So here in this case, we are not using actual cluster labels to test that whether we got the good clusters or not. So it comes under the internal measure. SSE is an example of internal measure. External measure, quality measure uses both ground truth clusters as well as the predicted clusters. So in this case, we are seeing two popular external measures, which is one is the clustering accuracy and another one is the RAND index. So to find the RAND score, we can import this function RAND underscore score using this sklearns from which is inside this sklearns.matrix package. And also I have made this clustering accuracy which calculates the check that whether the given which checks that whether the given predicted clusters are good or not. So to find what is the clustering accuracy for the given predicted labels, so you have to just call this function clustering accuracy, which needs two parameters since this is an external measure. So the first parameter will be predicted labels. The second parameter will be actual ground truth labels. Okay, so this value of clustering accuracy varies from 0 to 1. Greater the value of clustering accuracy means better the clustering results. So the value of clustering accuracy ranges from 0 to 1. 1 means the best perfect clustering, 0 means the poor clustering. So how this clustering accuracy is differs from the classification accuracy. So here the clustering accuracy also uses this confusion matrix, which maps confusion matrix. So let's print this confusion matrix. So in this confusion matrix, the rows will be the cluster labels and the columns will shows the ground truth labels. So here you can see that the value formula of accuracy is that sum of diagonal divided by total number of elements. So in the another challenge in while finding the quality of clusters using external measure is that we have to map the actual cluster labels and the predicted cluster labels. So to map it, our task is that to reshuffle these columns such that the diagonals will be maximum. Because of that, these are the we have written these codes, and here it is the final clustering accuracy after mapping and reshuffling the columns. So by just printing it, here you can see that this is the initial confusion matrix. After that, the columns of these confusion matrix got shuffled such that we got the sum of maximum diagonal elements, which is this, and we got this clustering accuracy, final clustering accuracy. The second external measure is the RAND index. To find what is the value of RAND index for the given predicted labels, you have to just call this RAND underscore score. Again, since this is an external measure, so you have to pass these two parameters, which will be stored to the RI value. The significance of RI value is same as clustering accuracy. It means that better the RI value means we got better clusters, lesser the RI value means we got poor clusters, and also its value ranges from 0 to 1. 1 means that perfect cluster, 0 means that poor cluster. So for this given iris dataset, the sklearn's k-means algorithm got run, and the cluster labels which is predicted by the k-means algorithm is this. And also when we are doing some performing some finding validity indices of these predicted cluster labels, so we got the SSE value as 78.94, we got clustering accuracy as 0.8933, and RI value is 0.8797. So by this, by some validity indices, you can measure that the given predicted cluster labels are good or not. Okay, so that's it from my side. There are still 4 minutes, so let's see whether someone is having doubt or not. Why isn't the array results same as of yours? Okay, I didn't got this question. Can you explain it once again? Array results same as of yours. The results of the, these array results. Okay, so this will be differed on by the different runs, because I have already mentioned that the results of k-means will be depend on the centroid initialization step. In each run, the centroid is initialized randomly. That's why we got the different results. That's why in each run we got the different cluster labels, which is this array, which I have already explained with this example also. So are there any other doubts or query, or anyone facing difficulty? You feel free to ask. Okay, and how many of you are able to run this code successfully? Any response? Okay, thank you. Any other doubts or queries? Okay, so stop sharing it.
So please feel free to ask if you have any question.
Okay,
Okay.
the last.
Hmm.
Okay. Yes, please. I think code is already shared with you all, so just run it. The most complicated thing in that code is you have to mount the drive and give the correct path of the file. That's it. Uh, we don't have to create the centroids. Uh, there are different centroid initialization methods are there. Some is the random centroid initialization, which we already saw. There is one also very popular centroid initialization method, which is k-means plus plus. So you will see in the definition of this that inbuilt function sklearn's function. and also there are still researchers working on it. It is the very popular challenge of k-means. So we don't have to usually give the centroids manually as an external parameter. But yes, there are very popular existing methods there to find the initial centroids. And then the k-means algorithm is the task of k-means algorithm is that um, to learn the appropriate centroids so that we got the desired centroid based clusters. Okay, so someone is having doubt in the second last cell. Let me share it once again. Okay, this cell. So in this cell, we are use performing the measure or the quality of the clusters using two external measures. The first one is the clustering accuracy. The second one is the RAND index score. Uh, okay, so the how clustering accuracy differs from classification accuracy. The first thing is that clustering accuracy uses the confusion matrix, but the task of this clustering accuracy is that we have to map the predicted cluster labels to the actual cluster labels. It means that suppose in actual cluster label there is one cluster label as 0, but for that cluster our k-means clustering algorithm predicted give that cluster label as 1. So there is some difference in the cluster label assignment. So for that we have to map it, which predicted cluster label value is mapped to which actual cluster labels. For that we are shuffling the columns such that we got the maximum clustering accuracy. So for that, this is the remaining code, and this clustering accuracy function will return the value of the clustering accuracy for the given predicted cluster labels and for the given actual cluster labels. And to get the RAND score, I am using this inbuilt function. Okay. How we will segregate the data file in practical field. Actually, okay, so for that you have to, I mean, the first thing is that um, data collection is an important part in the AI and ML approach. So it is the different thing, but it is an important thing, no doubt in that. And okay, so if to detect clusters, you have to learn that how to, you have to first apply it on the variety of clustering algorithms. Like there are many popular clustering algorithms which already discussed in today's theory session, and just apply it and on the basis of some desired measures, uh, check that whether for what algorithm we got the better measures or validity indices, and use that, select this clustering algorithm. What is linear sum assignment? Okay, so the linear sum assignment is the task of it is that uh, is simply to, as I already told, that shuffles the columns of this confusion matrix such that we got the maximum clustering accuracy, means that we got the maximum sum of diagonal elements. So, and linear assignment means that we have to map the row index to the column index so that we got the maximum clustering accuracy. So because of that, there is one function which we have used, linear assignment. Why we have used to improve the execution time. Otherwise, it will be the all possible pair of combinations, and the total execution time got increased. What exactly is the output of clustering by k-means? We have got some accuracy of k, but what is it the significance? Okay, so by k-means we got some clusters, means in each cluster there are some similar data points, and each data point you have assigned some cluster labels. So here for example, in this we got the cluster labels of each data point, means first data point having cluster label 0, second data point having cluster label 0, and so on. And to check that whether the given cluster labels are the good or not, for that we, as I already told you, that explained that we can use these measures as well as internal measures, which is SSE, and as well as some external measures. And the significance is that you have to study these measures. For example, in case of SSE, lower the SSE value means good clusters. Similarly, for these both clustering accuracy and RI, better the value means better the clusters. Okay. Are okay. I think you will get the materials later. Okay. Are there any doubts? Okay.
So, so I can see a lot of question answers here, and I believe that participants are enjoying.